Here is the cross-sectional view of a hydraulic jack used on board a ship. As we all know, most of the main engine and auxiliary engine components are hydraulically tightened with the help of hydraulic jack. In olden days, the jack has been operated with pneumatic pressure. Recent days, it's with the help of hydraulic oil or a lube oil. So, there are some salient features which we have to understand about the hydraulic jack. In this video, we will discuss some important points which most of the engineers don't pay attention on a hydraulic jack. Let's see that. Here is the hydraulic nut mounted on the bolt or a stud depending on the design, and this bolt or stud is stretched or pulled up within its elongation limit up to a predetermined oil pressure or torque, and after that the nut is tightened. This holds the main engine and auxiliary engine components in place and the compression or tension depending on its location and purpose. So, a basic hydraulic jack consists of a distance piece where we have through holes which we have access to the nut. We use a Tommy bar or a small straight rod to tighten or slacken the nut, which we will put through these holes and then engage or put inside the holes in the nut and turn the nut. So this is the distance piece, which is shown somewhat blue in color here, upon which we mount the hydraulic jack assembly. The hydraulic jack assembly consists of two parts. One is the moving piston and two is the stationary cylinder. There are oil holes drilled through the top portion of the hydraulic jack. Let's say here is the oil entry, and the lube oil or hydraulic oil pressure acts on the stationary cylinder, and then there is a vent plug where we have to slacken this and purge out the air before applying hydraulic oil pressure. After the air is completely purged, close this vent plug. It's usually tightened with an Allen key. This hydraulic oil pressure acts on the stationary cylinder, and this stationary cylinder cannot move down as this rests on the distance piece, and the distance piece in turn rests on the engine frame or the cylinder head. So these parts will not move down. Thus the hydraulic oil pressure will act in turn up on the moving piston and enables to move up. And as you can see in this diagram, the moving piston is screwed on to the stud. As the moving piston moves up due to the hydraulic oil pressure, it also pulls up the stud along with it, thus enabling it to stretch and giving access to tighten the nut. However, we can't keep on apply the pressure and keep on elongate the stud. There is a limit for that. This limit will be stated by the manufacturer in the manufacturer's manual. And every hydraulic jack will have a nameplate detail, and it will definitely say the maximum lift value. Usually the maximum lift of a hydraulic jack which is used on a main engine will be having up to 10 mm. It can be 20 mm too, depending on the size of the jack. This lift of 10 mm is the distance that the moving piston can move up in stretching the bolt, or it is the safe distance the moving piston can move, after which these O-rings, when stretched above 10 mm, might block a safety passage hole here, or it might come out of the stationary cylinder. It is for this reason the maximum lift of a hydraulic jack is stated. And there are some salient points which you have to note. Let's now concentrate on the O-rings. I will zoom the picture now. As you can see in this diagram, it's very evident that there are two sets of O-rings. One is the square or rectangle cross section backup ring, and other is the circular cross section O-ring. And one important point what you have to note down is one set of these rings is mounted on the stationary cylinder and the other set is mounted on the moving piston. So these both serve the sealing purpose. Once again, I stress on this point. This set of O-rings or the backup ring, the sealing rings together, is mounted on the stationary cylinder, and this set of sealing rings is mounted on the moving piston. So these perform the sealing action. The hydraulic oil pressure is equally transmitted and filled up in this space, and it acts on upon the O-ring. You can see these two O-rings over here prevent the oil leakage, and the backup ring supports the O-ring just to withstand such a high pressure. So the backup rings are positioned outwards and the O-rings are positioned inwards. And there is a safety hole provider or safety passage provided as shown in this figure. So it is obvious that at times there might, or when the hydraulic jack is under high pressure, let's say we are tightening the cylinder head, applying some 800 bar pressure, and this O-ring snaps off or gives way, the high pressure oil suddenly comes out and it might create some damage, or it might injure some operating personnel. For that reason, there is a safety hole through which the high pressure oil will be released to the safe area within this area. I mean, it comes here and then pours out over here till the pressure is released, thus enabling safety of the operating personnel. And what will happen if this O-ring breaks off or gives way? The oil pressure directly will fall underneath. So while operating such jacks, if you find there is an oil accumulation or too much of oil leak in this space, that means that the O-rings or the sealing rings here are given way. If this rings leak, the oil will come out and you can't build up the pressure. So it's very easy to replace them. There's a detailed procedure given in the manufacturer's manual. Depending on the hydraulic jack design, we got to replace these O-rings.